Now let's look at a very important topic in Java, and we have talked a lot about these topics while we were working in Java, and sometimes it might have confused you. So I'm here right now to clear all that confusion. We are going to study about memory management, how things are assigned memory in Java, and then any problem which might come with memory management, how to deal with them is something which we are going to see. Now for this, it's really important for you to understand that there are two types of memories which are available in Java. So you have a particular Java program, and from the operating system you have two memories. One is the stack memory and another is the heap memory. The stack memory and the heap memory both share the same space, but then as much as the Java wants to add things to the heap memory, it would grow. Similarly, as much as the stack would want, it would grow in the same shared memory. This is how a Java program with a memory block works. So you do have the program text, and then you have the data on which you are working, and you have the stack and the heap part as well. Now what's the stack memory? Stack memory is a simple memory in which you keep pushing things and then keep popping things from the same end. So you push at the same end and you pop from the same end. That is known as stack memory. And one important use of this particular stack memory is to store all the function and method calls. So there is one function, let's say, the first method which we call is main, right? And then main calls another method that is going to be pushed onto the stack. And that new method also calls another method. And then this is how, the stack might keep on growing. And as soon as a method completes execution, then the stack would pop off that particular method block. And then, the second last portion or the second last method which was running would continue to run, and this is how we would come back to the main method which would complete its run and then terminate the program. So stack memory is really very important for keeping function calls or method calls in the memory so that we know where we are supposed to go back when one particular method completes execution. The next thing which stack memory is used importantly is to keep references of variables. So we always created new variables, let's say in the main method, right? Where are these variables stored? These variables are stored in the stack memory itself. Another thing is that, all the values of the local variables in each method block or a function block and the program counter, all those things are also stored in the stack memory. Now, for example, if you have this particular static method, factorial, which is returning an int and taking an int, this is just to calculate a particular number's factorial. So we do have, let's say, for example, if it is n factorial, so 0 factorial is 0, 1 factorial is 1, but 2 factorial is 2 into 1, and 3 factorial is 3 into 2 into 1. And this is how it keeps going, right? The factorial n into n minus 1, so on till 1. So if it is equal to 0, then we would return 1. Else we would return n into factorial of n minus 1. And this is known as recursion. We are calling the same method again within its body. And this is how, the function or the method of factorial is written. Now, when we actually try to run this, one method call of factorial is calling another method call of factorial just by changing the argument value. And what this would essentially do is actually insert the factorial call onto the stack, and then let's say, for example, the factorial of 4 would call factorial of 3, which is going to be pushed, and then factorial of 2, which is going to be pushed, factorial of 1, which is going to be pushed, and then factorial of 0. But once the factorial of 0 reaches, then we know that this is going to return 1. So we would return 1 from here, and this particular method block is going to get popped off. And then again, factorial of 1 is going to be popped off, it would return 1. And then factorial 2 is going to be popped off, and it would return 2 into 1, which is 1. And this is how, it would factorial of 3 would return 3 into 2, which is going to be popping 6. And then, finally, factorial of 4 is going to return 6 into 4, which is 24. And that's how it is going to pop off 24. And this is how, the entire execution of this particular factorial method is going to get complete. And you are going to get the result of 24 from factorial of 4. So this is how the stack memory is going to be used for all these method calls. What about the heap memory? Heap memory is going to store all the defined variable values. So you have this particular stack memory and you have all these references to the objects. But where are those objects stored? For example, I created a student class. I created an object of the student class known as S1. Where is this S1 stored? that S1 is actually stored on the heap. This is the heap memory, and these are all the objects in the heap, and these are the references to those objects. So we have the object in the heap, but the references are in the stack memory. So as I said that if I just do a student S2 and I assign S1 to S2, what's going to happen is that the object is the same in the heap, but S1 and S2 both are going to be referring to the same object on the heap. So for example, over here, you can see that this is a stack and we have a local variable int a equal to 10, and a equal to 10 is put onto the stack. Now, if we have an object instead of, a simple local variable, a primitive local variable, we have an object. For example, test a equal to new test, and a is the object of the class test. So a is the reference which is going to be present in the stack, but then the heap is going to have the object, and this is just going to refer to that particular object in the heap. So now in a particular Java program, you have this particular JVM memory, and this is going to be divided in the heap memory and the stack memory. So now heap memory is going to have, all those objects which your program is working on. These are all live objects in the heap memory. And then you may have one or more threads in the particular program, and each thread would have its own stack memory, and each thread would be calling, the methods one by one with their local variables. So this is calling the method 1 and storing the local variables of method 1, and then, it had called method 2 with this local variable 1. So this is how you would have stack memory for different threads and a common heap memory for all the threads. So as I said that if we do have, a string S1 and, for example, I'm putting the value of 1 over here, we also have a string S2 with the same value. Now these two would not be considered different. We just have one particular object on the heap with the value 1, and both of these are going to actually point to the same thing. So if I change anything in S1, S2 is also going to reflect that change just because these two are pointing to the same thing. Similarly, if we create a new S3 with the same value 1, but now using the new operator, this is going to be, at a different place altogether. Now, if we actually try to compare S1 with S2, is S1 equal to S2, this is going to be true just because it's pointing to the same thing. But if I compare S1 with S3, this is going to be false just because it's actually pointing to different things. So you really need to make sure that whatever you are working on, you know how memory is assigned to all those things. And in case you are confused, you can just, do these checks just to make sure that, whatever changes you are making to S2 should not actually hamper what is there in S1 or any other object. So Java has, a couple of memory parts. You would have the heap area, you would have the method area, you would have the stack, you would have a native method stack, and you would have, all the program counter registers also stored. Now, memory management is an important thing in Java because sometimes we may land into problems working with memory. Every program has a limited amount of memory to use from the cache or the main memory, right? Now, there is the stack, and you have one stack per thread, and all the local variables relating to that particular thread method calls are going to be stored in the stack. You have the heap, which is massive. You can store all the objects in the heap, and this is, the common thing for all the threads, and all the objects are stored over here. Now, if your program is using a lot of memory and, the heap actually gets overflowed, then you would have some problem with, memory overflow or memory leak problem or out of memory error. Now, what are memory leaks? Memory leaks occur when, memory that has been allocated is no longer needed, but it does not get released for, any other part of the program to work on. So we allocate memory using the new keyword, right? So we create different objects using the new keyword, and we allocate heap memory for those objects. Now let's say you are not using those objects anymore, but the memory does not get released. Then your program would keep on, assigning things to new objects, not releasing it from the old objects, and now you do not have any more memory left for any new objects to be created or for the, for the remaining of the program to use any new memory to complete its execution. And that is where out of memory error comes. And we do not want these kind of errors, right? So we really need to solve such memory leak problems, which is not allowing our program to release any unused memory. Now for that, we really need to understand that the new keyword is going to allocate memory, and the JVM might move this memory around, as the program runs. So it's not a particular place which the object might be allocated, but it would be allocated some memory anywhere in the heap. Okay, and this memory is not going to be freed until the reference of that particular object is live on the stack. Okay, so we just saw that the reference is present on the stack, right? If it is live reference on the stack, it is not going to be freed. Until you free that particular reference, that memory is going to be kept in use. The automatic thing which Java uses to free memory is known as garbage collection. And this is a pretty magical thing which happened in Java. So in earlier programming languages, before Java was developed, which was, for example, C or C++, then we actually wanted to create memory using the new keyword, but then every time we actually create a new object using a constructor which is the same as Java, we actually also had to create a destructor for that. That's a pretty logical thing, right? You have a constructor, so you obviously also need a destructor. Always the destructor had to be called to free the memory if the object is of no use. And that was the problem which was put on the shoulders of the programmer. The programmer has to make sure that, all the objects which are not referenced are freed. But Java actually took that burden away from the programmer and gave it to an automatic method of garbage collection, which automatically checks if there is any object which is not yet referenced, by the remaining program. So why not just free that memory up and remove that burden from the programmer, just in case, the programmer forgets to free that particular memory. And that is known as garbage collection. And that really made a lot of difference in programmers' life. And that's why people moved a lot towards Java as well. Because of this automatic garbage collection, there were no more memory problems because of not freeing objects once it is allocated. Now, what is a memory leak problem, if you ask? So memory leak is actually a situation when there are objects present in the heap, but they are no longer used, and the garbage collector is unable to remove them from memory. And that's why they are unnecessarily maintained. And that would actually cause, memory overflow or out of memory error. Memory leaks, they are bad, okay, because it blocks memory resources and it degrades system performance over time. Now, obviously, if you have a lot of things in the memory which are not used, they're unnecessarily taking memories, and you have very less memory remaining for your program to work on. That means the program would get slow, right? And if this particular memory leak is not dealt with, the application will eventually exhaust all its memory resources and finally terminate with an out-of-memory error. So, we want to avoid, in any case, any memory leak problem. Now, remember that there are two types of objects in a particular heap memory. One is referenced and one is unreferenced. So, reference objects are those who have still, active references within your particular application. Whereas unreferenced objects are those that do not have any active references. So the garbage collector is actually going to remove all the unreferenced objects periodically, not like every single microsecond, but periodically it is going to actually work for garbage collection while your program is not doing anything specifically, heavy. Then that time is going to be used by the garbage collector to actually free that particular memory. But then it will never collect those objects that are still being referenced, right? And that's where memory leaks occur. So we do not want that, there is any severe performance degradation when your application is actually continuously running for a long time. We do not want any out-of-memory error for your heap in the application as well, right? And we do not want any spontaneous or strange application crashes as well. So for that, we really need to understand what to do so that we do not have a particular memory leak. And there are a couple of ways to do that. Now remember that if we avoid any particular memory leak, then we definitely have all the advantages of garbage collection. So what are the advantages? One is that it makes Java program very memory efficient, because the garbage collector would remove all the unreferenced objects from the heap memory. And another is that it would automatically be done by the garbage collector, which is a part of JVM. So we don't need to make any extra efforts. Now, as I was talking that, we can make an object unreferenced once it is, no more of use. And there are a couple of ways by which you can do. The first is by nulling the reference. To show that to you, let me just create a new file. And I would just call it memory management. And then this, I'm actually trying to have a main method, and within this, let's say for example, let's create an object of student called S, and I'm just going to create new student. So now we do have this particular S object, and let's say for example, after a lot of working, I do not need S anymore. So what we can do is, we can simply assign null to S, and then, after this, whenever the next time garbage collector is going to work, it's going to see that, S is actually not referring anything. So S is on stack, but then, it's not actually pointing to anything on the heap. So let me just clear S. So this is one way which you can do. Also, for example, you have, two more students. For example, you have S1 and you also have S2. Okay, so now you have these two live references, S1 and S2, and these are not going to be garbage collected just because we are actually pointing them to new students in the heap as well. So for example, I actually do S1 equal to S2. So now what's happening is that whatever S2 was pointing to, which is this particular object, now S1 also points to this particular object. Now what about this object? This object is no more required, right? So whatever S1 was pointing to, that is no more required, and that's what is going to be collected by the garbage collector. So now this object is going to be garbage collected as S1 points to something else later on. This is how you can actually, free this particular object over here as well. For example, if you are just working, on a simple instance, for example, you are doing a method call and then, you are wanting to pass S1. Instead of doing this, you could simply, pass a new student, and this is just going to make sure that this is anonymous. It does not have any name or any reference on the stack, and that's why, you don't actually need to create a new reference and thereby, not allow it to be garbage collected, because once this method call gets complete, then this anonymous object is going to get garbage collected. Is going to be garbage collected once method call completes. So this is how you can actually, make sure that your objects are garbage collected. Now garbage collection really works with specifically, two methods, and both the methods are finalize and GC, and these both methods are available for us from Java itself. Basically what we can do is we can actually override this particular finalize method. For example, in this memory management class, I can actually create this particular public void finalize, and in this finalize, the spelling, make sure it is right. In this particular finalize, I would just, do a simple sysout that, garbage collected. That's it. I would just write garbage collected. So this finalize method is actually going to run, and it's actually going to do some garbage collection, and it's going to do a simple sysout for us now. And in this main, for example, I'm creating a new object of memory management. So memory management n1 equal to new memory management, and similarly, I would do memory management m2 equal to new memory management. So now we have these two objects, and now I actually want to make m1 to be null and m2 to be null. So this is how I really want to make sure that, the next garbage collection happens. So now instead of waiting for, till when the garbage collection would happen by the JVM and by my operating system automatically, I'm going to actually call system.gc. So this is going to be in capital system.gc, and this is actually going to call the garbage collection for me. So when I try to run this now we do not have any particular, output over here. And the reason for that is that, when we do call a garbage collection, it is not necessary that every time it's going to be garbage collected using this GC call. But if I try to actually run it a couple of times, we may, be lucky enough to get, that, both these objects are indeed garbage collected. Now, as you can see, we did get, garbage collected for one of the objects right now. And remember that this finalize method is actually going to be overridden. So we can actually add an override annotation over here as well. Let me just, make the formatting a little bit proper. So now when I actually try to run this, it's not necessary that we do get it garbage collected, but sometimes we may be fortunate to see that, both the things M1 and M2 are garbage collected and this finalize method is called. So I'll try this a couple of times now. So right now I did get, a scenario in which both the, M1 and M2 objects are garbage collected. So now this is one way, in which you can force the program to sometimes garbage collected, or you really don't need to do it. You really don't need to, worry about that. Just because you made it null at any particular garbage collection cycle in your Java program, it is going to get garbage collected. So you would not have any memory leaks problem. Also, another time in which you may have a memory leak problem is probably if you use static, huge data. For example, if I have a public static, integer array, and this is going to be new integer, and let's say, I have a big array, for example, over here. And then, every time I create this particular, I want to actually use this particular array, this is actually going to get created just because it is a part of the class. And let's say, for example, in main, after this whole thing, let me actually call a method. So let's say, for example, I have a method over here. So for example, I have public void write to array. And then, for example, I run this particular for loop for int I equal to 0, I less than, this whole big number, and I plus plus. And then what I want to do is basically, I want to add to this particular array the value of I. So at every, index, I want to actually put the value of I or any other value. For example, I just took this particular example over here. And then, for example, I actually call for a new object of memory management, let's say M3, and then I call M3 dot, and then I call, the write to array method. So what this is going to do is, it's actually going to create this whole new array, write to this array, for me. And then, this is going to take a lot of space in the heap, right? And now once my program gets complete, you would not be able to see, how much memory we have written just by creating this particular array over here. But even though now we do not use anything in M3, this static keyword is actually going to, let this particular array be there in the memory and then cause, memory issues for us. So instead of this, if we did not have, static, for example, instead of this thing, we did not have it static, we just had it, a simple integer array, 1, for example. So if I actually worked with array, this is going to give me memory leak problems. But if we used, something like arr1 I equal to I, so this doesn't give memory leak issues. And the reason is simple because, this is based on this particular instance M3. So once we wrote to the array, and then, once, for example, once we made M3 equal to null, then this is going to be garbage collected and we would not have any memory issues. But this particular part, even if I made M3 to be null, but I actually wrote to this particular static, big array, then this is going to give me a lot of memory issues. So I will just comment this part out, just to make sure that, this is a problematic code, and that is indicated to you pretty well, that, if we do have any static fields, and even if, we actually use that particular static field with an object and we make that object null, but, just because it is present with the class. That's why, it's going to take a lot of space in our memory as well. And the last thing which you really need to know, and you might have thought, while we are talking about memory, is that every time I actually open a particular resource, so any resource, for example, it could be a buffered reader or a buffered writer, or anything relating to different files, different, let's say URL connection which I open, or any resource if I open, so this is for an example I've written, but any resource if you open and you do not close it, that is going to make a resource leak problem, right? I told you earlier. So this resource leak problem is actually going to result in memory leak issues as well, because resources take up memory, right? And if you do not close the resource, it's going to take up that entire memory for the entire amount of time, and you are going to land in some troubles with memories as well with that. So make sure that you always, when you open a particular resource, you are closing it to avoid any memory leak issues. Now finally, even if you make sure that your code does not have any of these problems, for example, you're working with a big software and you do get an out of memory error or a heap memory error, then what do? You need to understand that even though we have put in so much of effort, and even though garbage collection is something which is pretty good in Java, it does not prevent all the memory leaks, right? So we have some tools which we can use to check how much memory of the heap is being used at any point of time, and then we'll be able to see which thread or which process or which method call is actually causing this whole amount of memory to be used in the heap. And some of the tools, I would just name it for you. One of the tools is JPS, and another would be called JVisualVM, or you could use Java Mission Control tool. You could actually install these tools and use them, and these would give you, the memory usage for various programs which are running. The image which you do get is known as object histogram, and that is basically listening of how much memory you are using, and all the different types of objects which are using your memory, and what is in the heap currently. So this is something which you can explore if you do land into some memory issues, but let's just keep it at this, because the usage of these tools and everything is out of the scope of this particular course, and you may not even need it just because you have coded it pretty well. But just in case you do land into some memory issues, then there are these tools and many more different tools available to check memory issues within Java. So we have covered a lot of memory management things in this particular module as well. Now let's go ahead and actually take up the last topic in Java.